Hello everyone, can you hear me?
Yes, sir.
The lab will be 12 o'clock cooked. Yeah. Good afternoon, everyone. Okay. So in this session, we'll be discussing week one of the machine learning foundations. Okay. So mainly we'll focus on the activity and the practice assignment questions. Okay. But in the activity and the practice assignment questions, if you have any doubts regarding the concepts or anything, we could go into that and discuss more on that. Okay. Is this clear? Like, is the agenda clear?
Yes, sir.
All right. So how many of you have looked at the contents of week one?
Yes, I. Yes, sir. I
Yeah,
was.
you can just raise your hand if you have looked at the contents of week one.
Excuse me, sir.
Yes.
Hello, good evening, sir.
Yeah, good evening.
Sir, I am facing difficulty in solving the calculating loss problems.
Okay. What is the difficulty you are facing?
Sir, means I don't know how to calculate them. I can put the values in the given function, and then I don't know how to do further, means how to proceed further.
You just need to sum up the minus log, the negative log values, right? For all the values there. I mean, for all the x values there. Right. Okay. We'll discuss that once we get into the problem. Okay.
Okay, sir.
Okay. So only 5 people have looked at the contents. Remaining haven't got the time to look at the contents. Nine. Okay. Okay, so the week one is just a basic introduction to machine learning. Okay, like we just discuss the basic terminologies and the different types of machine learning problems that we will encounter. Okay, and just a brief idea of what machine learning is all about and how is it different from the normal programming and the human way of solving problems. So that professor has explained very clearly. Okay, so it is totally alright. Like you could still be following even if you did not look at the lectures. Like you could still follow the live session. Okay, if you have like some idea of machine learning, you can still follow this live session very well. Okay, yeah. So we will get on. We'll start the session. Okay, are you able to see my screen?
Yes, sir. We can.
Okay. Okay, so I won't be discussing the each and every concepts, okay, because that we'll be doing in the open session. Okay, so what I'll basically do is we'll just go over each of the activity questions, okay, and then I'll be asking you to answer those questions, okay, like I'm not exactly answering, but then if you have any doubt in that particular question, like regarding the concepts or why that particular answer is correct and why some particular option is wrong, we can discuss over there. Okay. All right. Okay. So yeah, is this okay, or like do you want the live session to be in some other manner?
Sir, it will be good if you can go through some important concepts covered in this week actually, because most of the guys didn't cover the whole week content. So they were unable to relate with the exactly activity questions.
Okay, fine. So, but then I won't be okay. I will discuss those concepts, but then I won't exactly get into the details of it. Okay, is that okay?
Yeah.
Okay. Okay. I will use the slides to discuss the concepts. Okay. Okay, so this is the first lecture, okay, where we just talk about what is machine learning. Okay, so the machine learning, it's just like we use a computer algorithms that improves over data, right? Because that's all we basically know machine learning. We have input data, and based on the input data, the model is created. Okay, the model is created, and we use that model to solve for the that is to estimate the unknown values, right? For the unknown outputs based on the input, we estimate the output values. That's what machine learning does, right? Okay. So basically, with the new data, the machine learning algorithm, it improves automatically, okay, by the use of data. Okay. So these not exactly, I mean, these are not similar to normal program which we write where it is static. That is, irrespective of the data, we just have a simple straightforward way, okay, hard coding way of like solving a problem. That is, for example, let's say let's say you're finding f of x equals to x square plus x plus 2, right? Something like it, okay. You have particular x value, and then you'll get the output, right? So even if you are like 100 data points, okay, the output of it does not, it's not going to change. We just use a same simple formula, the hard coded formula, to get the output. But with respect to machine learning, it could be different. Okay, so we do not know what the f of x will be. Okay, so what we know is, all we know is we know the x, and corresponding to x we know output. Okay, and if we get the more of the x comma y values, so our actual function will be changed such that we have better accuracy, and then like we will be improving, and then like we'll be betterly guessing the what this f of x is. Okay. Yeah, so these are some of the applications of it. Okay, so using for weather prediction and all, weather prediction, the space detection too. Okay, these tasks, it is not easy to it is not easy to perform manually. Even though the face detection can be done manually by us, it is not possible for us to go over like millions of images and then like detect those spaces, right? Though it is possible, like it's going to consume time and money also, right? Because we are like humans, and we work on time and money, right? So that is not possible. And when it comes to weather prediction, it's not entirely possible for humans to predict the weather. Okay, but then using machine learning algorithm, we could easily do that if you have enough amount of data. Okay, so this is how the normal hierarchy of how these three different things works. That is a manual labor in the sense like we have an input, and then like we know the output. Let's say like you're finding, you're solving for the roots of some quadratic equation. Okay, you know you have the equation, and then like you equate it to 0. You do it manually on pen and paper, and then like you use the output of those output of the x comma x2 values, right? I mean the quadratic equation roots. But then in the programming, the tool uses, what to do is the human directly creates this tool. That is, we create a program, okay, which directly which directly based on the input it will give the output. Okay, but then in the machine learning, what we do is we don't directly create the tool. What we do is we kind of like create the structure of how the tool should be, and then based on the data, based on the data the tool design, it will be creating a tool. Okay, it will be creating a tool. It's like let's say let's say we have a function which depends on 3 parameters x1, x2, x3. Okay. So the basic structure of how we can give it is like something like if my f of x1, x2, x3 will be equals to ax1 plus bx2 plus cx3. Okay. But I won't actually tell the I won't actually tell the computer these were the a comma b comma c values. Okay. I won't tell that to the computer. What happens is based on the data, that is based on the x1 comma x2 comma x3 and the output values, like based on some n number of data points, the a b c values are evaluated. Okay, the a b c values are evaluated, and the best fit of it, that is that is the best possible function for which we have this less error, that will be chosen. Okay. So this tool design is done by us, but the tool exactly we won't be doing it. Okay, that will be done based on the data. Okay, so as you could see here, as we move about like as we move further from manual labor to programming language to machine learning, the human intervention is less. Okay, basically we're trying to go to a point of like where the computer can actually do more of the talks which we normally cannot do. Okay, so which are not so straightforward, that can be done as we go further. Okay.
So just one question, sir.
Yes.
As you said, it will take the data
Hmm.
and ax plus by plus cz, it will find from the data what is the best value of abc, and
Yeah.
accordingly it will fit. This finding this abc, how it will find that abc from some optimization technique.
Right.
If you can show just one small example with some few data, how this calculation done, then it will be much more clear to us, I think.
See, how exactly we are going to calculate those ABC, right? That will be learning in the next few weeks. So the only thing which we need to look at is, let's say, consider it as kind of like we have this data points, right? If we consider just a single dimension vector, that is we have this x and the corresponding y values. Okay, x and the corresponding y values. Okay. So consider it like a scatter plot where we have different set of points. Okay, what we need to do is we need to we need to fit a line. Okay, we need to fit a line. Okay, such that the error will be the error will be very less. That is the estimated value through this line curve and the actual y value. The difference between those, that is exactly the square of the difference of that of the error rate, that should be less. So this we will be normally doing in the even if you go to Google Sheets also, the line fit and all, it will be done. Okay, so exact way of like how to do that. Okay, that's not so complicated, but it just takes time. Okay, so which we'll be covering in the later weeks. For now, all you need to understand is there is going to be some good fit. Okay, some good line fit. Okay, for the particular points, for any set of points, that will be done. What is the best fit? That will be, that will be calculated by the machine learning. Okay.
Okay.
Okay. So these are the reasons of why we will be using machine learning. Okay. So sometimes, for example, this face detection, even though we know what it is, what constitutes a face, we cannot easily express that to a program, right, directly. So in this particular scenarios, what we do is we just give examples of what a face is, and then based on that, the machine learning algorithm, it learns itself, and then when you give a new data, it predicts whether that image contains a face or not. Okay, so all we need to have for machine learning is we need to give the basic structural idea, that is the basic way of like kind of like basic function of like how to solve a particular problem. Okay, and then if you give sufficient amount of data to it, then it will produce the correct model for you. Okay. So this password verification is another example. Okay. So we'll move further. So this face detection I already explained. Okay, here directly by manual, by like humans, we ourselves we can detect whether it's a face or not. But through programming, hard coding, it is not so easy. That is, we cannot look at image and then like we cannot directly write a program. Okay, that detects whether that particular image contains a face or not. But through machine learning, we could actually do that. Okay, the software design is done with the exam, like with sufficient amount of data. Okay. Okay. So even the weather prediction, we do it in the same way. Using the radar map, it is not so easy for the humans, and using programming too, we could do it. But the thing is, there'll be lots of there'll be lots of things which are which is not very easy to transform it into the hard coded software, software program. So that's not so easy. Okay. So but with machine learning and with sufficient amount of data, that can be done with the better accuracy when compared to the program. Okay. So these are the examples of machine learning. So what we have is we have this n number of normal mails which we get, right? So this Gmail which we have, it classifies some of the mails which you send. It directly goes it goes either into the inbox or the spam folder, right? So based on the vast amount of data the Gmail has, it classifies it into either spam or inbox based on whether there is a subject or not, based on the domain from which we are getting the mail and other things. Okay. Even the shopping cart that is based on our purchases, the Amazon or Flipkart will be suggesting the similar products, right? So this is like very difficult for us to do. That is for like we cannot based on one single purchase or few purchases. It will be very difficult for us to guess what the next purchase might be, or like what is a good solution for the particular user. Okay. Even through software program, it might not be very easy, but then using machine learning and then like using the vast amount of data, that is what are all the previous items which he has bought, and then based on his likes, and then based on other users data too, we could actually suggest like better products. Okay, which the customer could actually buy. Okay. Even this smart assistants like the Alexa and the Siri and the Google Assistant, they all using machine learning algorithms. They first convert this our sound, right, which is nothing but a wave. They convert that to text first. Okay, text first. They should be converting that to English language. Okay, the English language. That English language it should be converted into commands. Like if I say to Siri, reduce my volume to 10% or reduce my volume by 10%. There is a difference in both of that. Okay, that first actually Siri should be understanding my tone. Okay, my tone and the way I say it, because the slang too varies from person to person. Okay, that too Siri should be taken into account. Okay, it should detect whatever I was trying to say, and then it should understand what it actually means. Okay, and after that it could make that particular operation. Okay, so that involves machine learning too. By having some various number of examples, it understands better, and then it performs the task better. Okay. So we have this machine learning. Using machine learning, we have this robots which operates in other countries. Okay, we cannot completely hard code these robots, because there'll be n number of scenarios which you might not expect. Okay, but through machine learning and the amount of data, it could actually make a better prediction of what it should be doing. Okay. Even in games too, we have this. We are seeing lots of examples of computer actually beating the world level athletes, right? The players like in chess and others too. Okay. The marketing anyway we know how well the machine learning algorithms works. Okay. So this is with respect to the first lecture. All right. Any doubts until now?
No, sir.
Okay. So we'll discuss all the lectures and after we'll go into activity questions. Okay.
Okay, sir.
So until now what we have established is we know that for machine learning algorithm to work, there should be a basic structure of structure. Okay, like how the solution should look like, and then like based on the data it will actually create a model. Okay, it will actually create a model. So through using this model, we'll and then like you per a particular input, it will be guessing the output. Okay, that's what machine learning does, right? So what actually we mean by data is it is a collection of these vectors. Like let's say like we are talking about estimating the price of a house, right? We estimating the price of house. So for that what is the data collection which we might be having? Some rooms, area distance to metro, and then like there could be like number of stairs on the windows, or the extra facilities which it has like garden and other things, right? So those are all the data points which will actually affect the price, right? So when we mean data, what actually computer requires is it is just a collection of vectors which will be actually numbers. So this 3, 9, 1.9, 5, 5.2, this corresponds to house 1. 2, 7, 2.1, 3.2 corresponds to house 2. Okay, actually using this data itself, we could actually predict the prices. Okay, this itself will be sufficient for computer. It doesn't matter what the units are, as long as we are following the same units. That is for this column, whichever units we are following for house 1, right? If you are following the same units for the remaining houses, it doesn't matter. It doesn't matter what unit it is referring to. Okay, as long as we are using the same units. Okay, so for example here, but then for us to understand what exactly is happening, we need to know what the units is. That is, the first column, it represents number of rooms. Second column represents the area in 100 square feet. The third column, it represents the distance to metro. And then the fourth column, it is a price in 10 lakhs. Okay. So for us to understand what is happening, we need this metadata. Metadata is the information about data. That is, this is the data, right? This metadata, it represents what the data is actually represented. Okay. Is this clear? What is data or not? Okay. Because at the end of the day, in machine learning, you do not have this units. All you have is some numbers, and then like using numbers on you predicting the outputs. Okay, output here our output will be this price of the house. Okay. So this any model is just a simplistic simplification of reality. Reality in the sense like what exactly affects the output. Okay, because even if you look at the houses here, there could be n number of things that are affecting the price of house. Okay, but then we cannot include all those things. We can only include some certain number of things. Okay, which will be kind of like a good representation, not the exact representation of the price, but a good representation of the price. Okay. So even the models which we have in physics and mathematics, right? They are also are the simplistic representation, okay, of reality. Even this gas model PV equals NRT, that is not exactly true. Okay. Validation data is the data with which we actually check for like how exactly our model is going to perform. Okay. For the validation data, we do not know what the output is. Okay, what the output is. That is the validation data. Okay. I will talk about it in the later lectures when that particular topic comes. Okay. So all these models, they are just approximations. Even this gravitational loss, right? That is just an approximation of it. It is not entirely correct. Okay. So as this code says, all models are wrong, but some are useful. Even in this particular scenarios, right? The model which we would be generating using machine learning, right? From this data, it might not be, it won't be entirely correct, but it'll be useful. Like by comparatively, it'll be useful. Okay. So there are like different types of models in machine learning. One is this predictive model and probabilistic model. Okay. So majorly we'll be discussing about this predictive model. Okay. The predictive model, here we are concerned with predicting what the output will be. In the probabilistic model, our main concern is we need to guess how well a particular output will be happening. Like what is the probability of a particular thing happening. Okay. There we know these are all the outputs that are possible. The only thing which we need to check is the probability of a particular thing happening. Okay, that is a probabilistic model. The predictive model, here we predict what the output will be. Okay. So in the predictive model, we have these two types: regression and the classification model. In the regression model, here we predict a numerical value, okay, numerical continuous value. But then in the classification model, we predict the categorical variable or discrete variable. Okay. We will discuss that with respect to examples. The good example for this regression model is predicting the price of a house. Okay, the price of a house is a continuous variable, right? So we'll be generating a models that predicts the price of that particular house. Okay, one model is this 0.5 into area minus distance. Okay, it included two variables here, area and distance, and based on those two variables, it predicted the price. Okay. In the classification models, what we do is mainly it will either be yes or no. That is the true or false thing. Okay. The one example is whether the room is closer than 2 kilometers to metro based on price and area. That is whether it is closer than 2 kilometers or not. Okay. That's the that is what we are going to predict, right? So either it will be yes or no. Okay.
So can it possible to it can be happen other than yes and no? So maybe 3 or 4 option.
That also could be possible. Yeah. Yeah, that also is possible.
Answer for the regression model. The output is always be continuous, or there is a possibility that there can be a discrete value also.
See, the output is always continuous because we do not have a restraint on the value. Okay, that it's gonna take.
Can it be taken infinite value then?
Yeah, no. like the limit is like infinite, but while predicting, we won't actually encounter value of infinite, right? The limit is there is no limit for the value it could take there. Okay, of course, if you're looking for the price of price of house, it won't be negative. Those are they're like constraints specific to the problem. But in general, it's going to be continuous. Like within that particular range, whatever we might be assuming that in that particular range also, at least it will be continuous.
So we can say that the values the output will always be within a range, right? Like we cannot fix on a particular value, right?
Yeah,
With the grid.
say that.
Okay.
We cannot say it will take only one of these values.
Can you mute yourself?
The number of values, like the number of possible values it could take is infinite. Okay, but if it comes to the classification model, the number of, the number of values it could take is finite.
Yes. Okay.
So I have a question. How this model is actually predicting? How is model accurate actually? 2 times rooms minus price is less than 1.
How accurate it is? That's what
No,
I question.
no. How is it a good model? I'm saying, where is this coming from? Random estimation?
This one. See,
Yeah. This model. Sir.
Model whether a house is closer than 2 kilometers based on price and area.
I think this will be 2 times area minus price because.
Okay. See, if you look at it, we have this price equals to 0.5 into area minus distance, right?
Correct.
Right. So the distance is going to be equal to 0.5 into area minus price.
Distance is going to be 1 minus area by price.
Okay, wait. We just discuss it in terms of this. Okay, price is directly proportional to number of rooms, right? Correct. Price is directly proportional to number of rooms, right?
Yeah.
And then price is inversely proportional to the to how close it is to metro, right? Because if it is close to metro, the price is going to be high. Correct.
Yes, sir.
Right. So
yes.
when we are going to since the number of rooms are high, the price is going to be high, right? So
yes, but it's not less than 1, right?
What?
But it's not less than 1, right? So in the ideal case, 2 times rooms will be equals to price, right?
2 times rooms, it will be equal to price, you're saying?
2 times rooms will be equals to price, right? For 0 equals to 0.
How come it will be equal to 0?
It's less than 1. Okay, so equals to 1, right? 2 times rooms equals to price plus 1.
Why it is equal to price plus 1?
Yeah. That's how my line will be. I'll be drawing the line like that, right?
Okay, you are saying that you'll be drawing a line, and then based on line you'll be saying whether it's close or not. That's what you're saying.
I'm just saying, sir, what is the logic behind choosing this model as 2 times rooms minus price less than equals to 1, less than 1?
No, they just making an example. Okay.
Okay, yeah, that's what I'm saying, sir. It's like a random, right?
Yeah, it's like random.
Okay, yeah. Thank you.
But then the only reason why they said it's a good model is the basic ideology they're following, right? And that is how close it is. How close it is. It is inversely proportional to price. So that's why they are making it as minus. Okay.
Yes.
If the number of rooms are high, then it won't be close, right?
Yes, sir.
Okay. So
yeah.
That's the thing. Based on that only, they said it's a good model. Okay. Okay. So the one other way of this probabilistic model works is, here as I told, right, we won't be worrying about, we won't be predicting it. Here the only thing we do is in probabilistic model is how certain a particular event can happen. That's a question there. Okay. Here the question is, what is the probability that a randomly chosen person is at a latitude longitude of 25 degree north and 30 degree east. Okay. So here we need to predict the probability of this particular thing happening. Okay, the randomly chosen person being at this particular latitude longitude. Okay, this is a probabilistic model question. Okay. and this towards the probability that a particular feat was generated by Mr. Chopra. Okay. So this learning algorithms, what we have is we
Sir.
just have, yeah.
Sir, I have one question. So we have two types of modeling. One is predictive modeling, and another one is probabilistic modeling. Under
Yeah.
predictive modeling, we have regression and classification. And under probability, what we have, sir? I mean, what type of modeling we do? Because for probabilistic, we have only one slide. So
Yeah, we have this. We have two models here. One is this. One is the dimension reduction, and then the other one is the density prediction.
oh, okay. Though both are comes under probabilistic models. Okay.
Yeah. We will be discussing that in the later lecture of this.
Yeah, correct. Yeah. Thank you, sir.
Okay. I told you that based on the data, we will be having these models, right? Okay. The learning algorithms, what it does is, okay, within the same structure, that is Ax plus, like, take the example of the f of x1 comma x2 comma x3. Okay, that the basic structure of that is the basic structure of the model is ax1 plus bx2 plus cx3, right? So based on this different parameters for the different values of ABC, we get the different models. We get the different models. From those collection of models, we will be selecting a model, that is, we will be selecting a value of ABC, A comma B comma C, specific values of A comma B comma C, which gives the best. I mean the best model. That is those ABC are the best parameters. In this example of price of a house, right? We have this A into area plus B into rooms plus C into distance to metro, right? Based on like different values of ABC, you get the different models, right? But the best model or the best parameters, there'll be only one specific base parameters A comma B comma C that we'll be getting using this machine learning. Okay, that will happen only with respect to the data. Okay, if you have more amount of data, we will be predicting the better values for this A comma B comma C. Okay.
Sir, I have a doubt over here.
Yeah.
So how to choose the structure of the model? I mean, whether to take the linear or the non-linear. Like here we have chosen like A into area plus B into room. So these things are how to decide.
There is no one specific way of like, okay, this is the base structure. There also what we do is we choose different structures. And based on the different structures, we will have different base models, right? And then we compare this. We compare these base models of different structures, and then based on the accuracy only, we will be choosing a particular structure based model.
So
Okay.
using the validation data, right, sir?
Using the
validation data.
Yeah, using the validation data. Yeah. Okay. Yeah.
Excuse me, sir. So, okay, over here you said about the structures, right? Similar structures. Yeah, over there, earlier in the slide we saw that data is basically it's a vector, right?
Yeah.
Okay, so over here, do you mean that we are taking the same size of vectors or something like that?
Same size of vectors, same dimension of vectors?
Yeah, the dimension of the vectors, yeah.
See, whenever we have the input, right, the input should be of d dimension, right? So all the input dimension. So yeah. Can you mute yourself?
You have to mute yourself.
Others mute yourself. Okay. Yeah. So give me a minute. I'll join again. Like.
Sir, are you there?
I think he said that he would rejoin.
Yeah. Yeah. Hello.
Yes, sir.
Hello. Hello. Can you hear me?
Yes,
Yes,
sir,
you
you're
are
audible.
Yeah. Okay. Okay. So based on that, you're talking about the dimensions, right? D dimensions, right?
Yes, yes. So
Yeah. So all the input data, it should be having the same D dimensions for us to for us to estimate, because we need this area, rooms, and distance to metro, right? For our model, this model requires these values. So
Yeah.
we need to have this 3 dimensions, definitely.
yeah, so my question was, is that what is being implied when they say with the same structure?
Can you repeat?
So it says that this learning algorithm, right? It chooses the best parameters
Yeah.
by
Yeah.
choosing, like it goes through models with different parameters, but with the same structure, right?
Yeah. Yeah.
So by same structure, do you mean that it has the same dimension? Like all the input, all the data has the same dimension?
Yeah. Yeah.
And
It should
metadata.
be having the, see, irrespective of the model you choose, it should be having the same dimensions. So yeah, it should be having same dimensions.
Same dimension and the metadata as well.
Yeah.
Right. Okay. Sir. Thank you.
Okay. So the just a same revision of it. Okay, what we have is we discussed about this human and tool design, right? So with the data which we have, we'll be generating a tool. The same thing, the tool design is this learning algorithm. That is the basic structure. Same structure we talk about, A into area, B into rooms, and C into distance to metro. That is the learning algorithm. And and if we give the data to it, then it will be generating the model. Then our machine learning algorithm, it will be generating a model. Okay. Clear?
So one question.
Yeah.
So
Yeah.
in machine learning, it will learn from the data which we continuously provided, right? So learning algorithm means it will learn from the data which we keep providing, right? So here in the previous slide, you have shown like I mean some coefficients like A into area, A multiplied by area plus B multiplied by number of rooms.
Yeah.
So
Yeah.
can I say that would be like starting point to consider as model, and as data increases, it will keep updating that model. Is my understanding correct?
Yeah. Right.
Okay.
As we have more amount of data, right? It will update the model so that the error will be less. Yes, correct.
Okay. So now my question is that the starting that model like A into area, will it be I mean constant, or or it will vary from one problem to another problem? I mean starting model, which model it will start? The starting point of
the starting model. See, if you're predicting the price, right? If you're predicting the price, and then if you're assuming a linear model based on these variables, then the starting model is going to be the same.
Correct. If we have some different kind of problem, then the model might change.
Yeah. Okay. Until now it's clear.
Yep.
Okay. We'll move on to third problem. So the supervised learning. Okay. There until now we talked about data, the models, and what the machine learning task does, right? Okay. So with respect to the regression, okay, we talked that the output will be a numerical value, right? So the real number R, right? Okay. So what we have is we have this d-dimension input vector. Okay, the d-dimension vector of real values. Okay, the just nomenclature which we are going to use, this RD means that we have a we have a vector of d dimensions. Okay, r means that real numbers, r plus means that positive real number. Okay, the x is a vector, xj is j in the subscript, which means the jth coordinate of the vector. Okay, all right. So if I mention like x3, right, x3 for this particular case is going to be 7, x2 is going to be 2, x1 is going to be 1. Okay, the modulus of x is going to be the length of the vector, which is going to be the square root of x1 square plus x2 square plus x3 square and so on, xd square, where d is the dimension of the vector. Okay, if you have the collection of n vectors, that is, we won't be having a single vector or single data point, right? We'll be having n number of data points, so we'll have n number of input vectors. Okay, so those vectors are represented by superscript, that x1, x2, x3 and so on, xn. Okay, they are the vectors. So xj of I means the jth coordinate of ith vector. Okay, all right, until now it's clear. xj of I and then x1 whole square means the square of first, I mean square of the first coordinate of x vector. Okay, when I mention x1 of 1 whole square, then that means the square of first coordinate of first vector. Okay, clear? And this 1 of 2 is even, or like what this basically means is, whenever I have this 1 of something in the bracket, the output will be either 1 or 0. Okay, if that particular value whichever we have in the brackets, if it is true, then that's going to be 1. If it is false, then that's going to be 0. Suppose here we have this 2 is even. 2 is even is a correct statement, right? So that's why it is 1. 2 is odd is wrong, so that's why 1 of 2 is odd is going to be equals to 0. Okay, until now it's clear? Hello, until now it's clear?
Yes, sir.
Yes, sir. Yes, sir.
Yes. So, can you repeat that last point? What is that one?
Yeah. Okay. So whenever we mention 1 of something in the bracket, right? 1 of something in the bracket, so the output is going to be either 1 or 0. Okay, only two possibilities. The output is going to be either 1 or 0. Whatever we having in the brackets, that is a statement which you're having. If that statement is true, then the output is going to be equals to 1. If that statement is false, then the output is going to be equal to 0. Suppose in this particular example, 2 is even is true because 2 is an even number. So that's why the output is 1. 2 is odd is false, that's why the output is 0. Suppose if you have like 1 of 4 is divisible by 2, then the output is going to be 1 because 4 is actually divisible by 2. Okay, suppose if you have like 4 is divisible by 3, then that's going to be 0 because 4 is not divisible by 3, right? Is it clear?
Yes, sir. Yes.
Okay. When we mention like supervised learning, okay, supervised learning, what that actually means is, we mentioned to the machine learning algorithm, this is the input, this is the output. We are actually supervising it while we are developing the model. We are telling to the machine learning algorithm, this is the input, this is the expected output. Based on this input output, you model your curve, okay, or you model your function. Okay, that's what we are telling. That's why it is called a supervised learning. Okay, because we are telling the machine learning algorithm, this is what I'm inputting and this is the output is. Okay, I'm actually telling this is the actual output I want. Okay, based on that you model the function. Okay, that's what we're telling. That's why it is called a supervised learning. In the unsupervised learning, we don't actually tell we don't actually tell this is the input and this is the output. There we don't actually have the output. Okay, we just have the input. It needs to develop some. I mean, what it needs to do is it needs to group the data. Okay, okay. I'll talk more about that later. Okay, but for now, supervised learning means that we are actually telling to the machine learning algorithm, this is the input and this is the output. Okay, this is the input and this is the output. Like that, I'll be giving n number of points, and then I'll tell to the algorithm, these are the n number of output values, and based on that, you model your algorithm. Okay, such that the error is very less. Okay, clear? So these what it was mentioned here. We have xm vector and then y1 vector as output. Okay, see, like this we have n number of input vectors and n number of output vectors. So based on this input output, the machine learning algorithm, it will be modeling itself, okay, such that it gives the best model. Okay, clear? This f of xi is the predicted value which is represented by ya. Sorry, f of xi is the predicted value. This f of xi, whichever we are predicting using our machine learning, right, that should be close to ya. Okay, that is our ultimate goal. Okay, clear?
Yes, sir.
Okay. So if you are predicting house price, right, from room area distance, so the room area distance, they fall under this x vector. Okay, x is of 3 dimensions. The first dimension will be room, second dimension, the second dimension is area, the third dimension is distance. Based on these 3 dimensions input vector, it should be predicting our house price. Okay, the house price, it is a single dimension, right? So that is a real number. Okay, so what happens is our algorithm, it has this d dimensions. In this particular example, it is of 3 dimensions. It gives a real value. Okay, for a regression, because for a regression we will be actually predicting a numerical value. Okay, so the loss function, which while I was talking about here, I was saying that f of xi should be close to y, right? So our model will be evaluated based on how close it is to actual value. F of xi is the predicted value by your machine learning algorithm, and y is the actual value. How close it is? Based on that only we need to decide. Okay, the loss is defined by this f of xi minus y whole square, the sum of all those losses divided by n. That is the average of the squared loss. Okay, our goal is to minimize this loss value. Okay, clear?
Yes, sir.
Okay, so since we have this x is a vector, right? X is a vector, so we denote this f of x as w transpose into x plus b. Okay, x is of n dimensions, d dimensions, so w also will be of d dimensions, so w transpose into x plus b gives a real number. Okay, this can be represented by this w sum of j equals to 1 to d wj xj plus b. Okay, so this wj is the
so the transpose is because of the weights are in vertical vectors.
Yeah, because we always mean this w as a vector, right? X is of n cross 1, right? And w is also of x is of d cross 1, and w will again be d cross 1. So we cannot multiply that. That's why we need to transpose the w. Okay, even if you do x transpose w also, it's going to be the same. Okay, clear?
Sir, what is W?
So not
is the
clear, sir.
parameter.
Yeah.
So
that point can you please elaborate?
What?
I'm not clear about that point. F of x equal to w transpose x plus b.
Okay.
Can you please elaborate a little bit?
Okay. So we talked about this price equals to a into room plus b into area plus c into distance, right? Correct. So what is x here? X is room area distance, right?
Correct. Parameters.
So w is going to be equals to abc.
Coefficients. Yep.
W is going to be abc, and then x is going to be equals to room area into distance. How do I multiply these two? W is a vector which is of abc, and x is a vector which is room area distance. How do I multiply this? What I need to do is I need to do is w transpose into x, which gives me a into room plus b into area plus c into distance. Okay. Clear?
Okay.
Yes.
Yeah. Now clear. Thank you.
Okay. Yeah. So here, this is a simple illustration where we have this x is a simple dimension.
Excuse me, sir.
Yeah.
Why are we adding b, that constant, to f of x?
This is just like our predicted value, right? a predicted value, it could be, I mean, it could be having some content also. No?
Okay.
Okay. Whenever all of these values of, let's say, room area distance equals 0, it could still have some value. The price the price need not be 0.
One order running late.
Okay.
Okay, sir.
Yeah. So when I mentioned that that error, right? So suppose we have this x values of 1, 2, 3, 6, 7, and then y values of 2.1, 3.9, 6.2, and so on. Okay. So we have these two models, that is based on the x values. Suppose there are like two models. We have this 2x1 and g of x equals to xn plus 3. Okay. Based on these models, we will be predicting, right? That is f of xi and g of xi. We have predicted it. So the loss function we have calculated, whichever has the minimum loss function, that you will be choosing. Okay. From this, it is very clear that f has a minimum error because f is close to y when compared to g. G is far from the y values. 2.1 is close to 2 and compared to 4. Similarly, 4 is close to 3.9 than 5. 6. So 6 is to both are fine. But then when it comes to 12 is close to 11.5 than 9. Similarly, 14 is close to 13.9 than 10, right? So that is why f is the best model among this f and g. Okay.
Sir, I have a question, sir.
Yeah.
Yeah, how do you say ki this 2x1 is the best function? There may be 3x1, there may be 10x1, there may be x1 minus 10. Or
I'm only comparing these two models f and g. I'm not comparing this f model with respect to anything else. Okay.
Suppose, sir, this x and y value is given, and I have to find this whether it is 2x1 or x1 plus 3 or something else, that function. How can I do that?
So you could calculate the loss function. Okay, the loss function value for both the models, whichever has the minimum loss function.
No, sir. Loss function for if the two model is given, suppose this 2 and here is 3, these two value you have. Suppose you do not have this value. Instead of 2 or 3, you have A and B. So first, from the point, you have to find which A and B I have to choose. How can I find that A and B?
You're talking about f of x equals to ax plus b.
Yeah, so you just go above, sir, a little above. This loss function, f of x equal to w transpose x plus b, where you are in the summation writing wj and plus b. How you find this wj and b from the given point?
See, that's what I already told you this.
One order running late.
This comes in the later parts of the week. How exactly we'll know the best values for this A and B. We'll come to know later. Now all we are doing is we're just comparing different models, and based on this loss value, based on the square loss value, we just saying this is the best model when compared to the other one. That's it. Okay.
Okay.
Yeah. Okay. So here also, we just done that same thing, but then it is just for a higher dimensions one. We have this rooms area distance, and then we had the price. Okay. We had this f equals 2 plus rooms minus 0.52 distance. Based on that, we got this 1f. Okay, that is one. We got these values, and then the different model is g equals to rooms plus 2 into distance. Okay, based on that, we got the different values. So by comparing these two models, f and g, we clearly see that f is a better model. Okay, as the values of f are close to the actual values, that is actual price values. Okay, clear?
Yes,
sir. Clear, sir.
Okay. So now we come to the second part of this supervised supervised one. Until now we looked at the regression. Now we are going to look at the classification. Okay. So here mostly in the classification we have this. Here the output could only be the discrete values. Okay. Generally it will be either like yes or no, true or false, something like that. Okay. So in this particular example, the question is predict if the rooms are greater than 3 from area and price. Okay, I will give you the area and price. You need to predict whether the number of rooms in that particular place is greater than 3 or not. Okay. So here the input values that is expected, it's going to be price and area. Okay, the output is going to be true or false. Okay. So in this particular scenario, what we do is we have this +1 and -1. Okay, +1 means true and then -1 means false. Okay, that is +1 means it actually has the rooms greater than 3, and -1 means it has the rooms less than 3, less than or equals 3. Okay. Here the loss function you won't be actually subtracting the values. You won't be actually subtracting the values because it's not a regression problem. We don't get we are not worrying about the value there. Okay. Here, since it is a discrete value, we just care about whether that actual value which we predicted is equal to the actual. The value which we predicted through machine learning is equal to the actual value or not. Okay. If it is not equal, then others please mute it.
అదే అబ్బాయికి అబ్బాయికి ఎంత గట్టిగా
Okay. So here what we care about is we care about 1 of f of x not equals to y. Okay. If the predicted value is not equal to actual value, then our loss function value it will increase. Okay. So basically what this actually means is it is a fraction of training data which is classified wrong with that. Suppose if the actual room has rooms greater than 3 and then we predicted that it has rooms less than or equals 3, then that is a wrong prediction, right? Even the opposite also. Suppose if it has less than 3 rooms, less than or equals 3 rooms, but then we predicted it has more than 3 rooms, then that is also a wrong classification. Okay. So we look at the data, the fraction of training data which we classified as wrong. Okay, that is a loss function. Okay. So we need to have this +1 and -1, right? The output of our algorithm, it should be either +1 or -1. How do we actually do that? We just look at the sign of W transpose X plus B. We use the same linear approximation. Okay, but then instead of looking at the value, we just look at the sign of it. Okay, if the sign is positive, then we take it as +1. If the sign is negative, then we take it as -1. Okay.
So I have a small doubt.
Yeah.
So the thing is here, I want to use either a positive value for plus values and negative values. That's how it will separate. Okay,
Yeah,
so
yeah,
let me.
yeah.
Okay, so another example would be, suppose if I want to know how many have scored more than 50, then I have to scale that -50 entire row, then plus minus. Is it? Am I making sense?
So come again. What is your question there? How many have scored more than 50?
More than 50, let's say. Then I have to take 50 out of every student score, and then whether it's positive or negative, on that I'll choose whether that person has scored more than 50 or less than 50, right?
Yeah. See, the thing is based on your value, the function itself is going to vary. So based on that it's going to be changing. Yeah. Here all that's going to happen is it's going to be the big value is going to be -50. That's it. Okay.
Okay, so
we have this W transpose. Here since you have only one dimension X, we have this W1 into X plus B, right? So the W is going to be equals to 1 and X is going to be your score, and then B is going to be -50. Okay.
Yeah. So if I don't want to delve into the negative values, then no other way.
Delve into negative values.
I don't want to go to the negative values for my function. Function of X is always positive. If a setup is there, then how will I classify it?
then the only way you can classify it is like if it is more than 50, then you take it as positive, and then if it is less than 50, then you take it as 50 directly. Okay. Yeah. Okay. So
this +1 and -1, this sign convention, it is just one of kind of example, right?
yeah, it is just one of a kind of example.
I can formulate this classification problem in many way. The way I want to classify it, I will set my criteria in that line.
Right.
Okay.
This is just a simple way of like classification problem. That's it.
Sir, one question. So, what is this sign? Sign WT mean? That I understand. W transpose X plus B. That part I understand. That before that sign, that I
sign it basically means that suppose we have the W transpose X plus B, right? W transpose X plus B, right? If it is positive, then the f of x is going to be +1. If W transpose X plus B is going to be negative, then it's going to be -1. Okay. If it is equal to 0, then we'll take it as +1. Okay. If it is exactly equal to 0, then we take it as +1.
Okay.
Arbitrarily, if we take it as -1 also, that doesn't matter. Yeah.
So I mean, just to for my confirmation. So you are saying that W transpose X plus B is let's say equal to 50. That is the number we got. So f of x equal to +1. Right. If it is if the value is -50, then f of x could be like -1. Just it's converting entire value into +1 to -1.
Yeah.
Okay, got it.
Okay. So we have the example here. So we have f of x equals sin of 2 minus x1. Okay. 2 minus x1, and g of x equals to sin of x minus 2x2. Okay. So based on this, they calculate this sign values +1, -1, and all. And then if you could see here, the loss for this f is 0 because it actually predicted the same values as the exact values. But then loss for g is it predicted one value as wrong. That is, it predicted the second value wrong. Actual value is +1, but then we predicted as -1. Okay. That's why the loss for g is 1/6. Okay. Clear?
Yes,
hello.
Sir. Yes, sir. Yes, sir.
Okay. Okay. So here also we just took it as the room is equal to 1, 2, 3. We just encoded as -1. Room is greater than 3. We encoded as +1. Okay. So here we took like different. I mean, that is different functions. The first function is sin of area -10, price -6, and price -9. Based on this, we computed we computed this FGH. Okay. And after that we can do this computation of loss. Okay. Okay, the loss function we would do, and then the fraction of wrong classification we could calculate whichever has the least loss value. Okay, then that's going to be the best model among these three. Okay, not entirely, but among these three. Yeah. Okay. So one person was talking about this evaluation data, right? So now we'll discuss that. Okay. So what's going to happen is, yeah, when the sign function gives the value of 0, then we'll take it as +1. Okay. When the learning algorithm, right, what we do is we actually divide whatever data that was given to us. We divide that into two types. That is training data and then the test data. Okay. So we use this x1, y1 values and then to get the model f, right? So we won't use all the data that was given to us. We divide that into two parts. Okay. We divide that into two parts. So that we will use some part for training, and then the remaining part we use for testing. That is, we won't use the output values yi. All we do is we just, based on the model which you get, suppose let's say like we have 20 points. Okay, we have 20 vectors, and then corresponding to 20 actors, we have the outputs. Okay. So what I'll do is I'll divide that into 10 points. Okay. You do not worry about why exactly 10. Okay. Just look at the concept here. Okay. We divide that into 10. Okay. So for the first 10, using the first 10 data points, I'll predict the model. Okay. I'll predict the model. So using the next 10 data points, I will actually test like how good the model is based on the accuracy of it. That is sigma of 1 by n into sum of I equals to 1 to n f of xi minus y whole square if it is a regression problem. Okay. So I'll calculate the loss value. Okay. I'll calculate the loss value. So based on the accuracy of the test data, right? That is the other data. I will remodel my data. I mean, I will change my model such that for the test data I will have the better accuracy. Okay. Is this clear what I was talking about? Hello.
The validation set is part of test set or train?
No, validation data is not part of test set.
So, but it's written the use test data that is not in the training data for model evaluation. Third point, sir. Yeah.
You use test data that is not in the training data. Huh. See, for model
Validation is
model evaluation is different. The evaluation data is different.
Yes.
Oh
See,
yeah.
model,
Yeah, sir. Got it.
But the validation data can come from training data, right?
No. The validation data for the validation data you won't know the actual output values. Okay, but for the test data you know the actual output values.
No,
Okay.
so initially when I am selecting the model, I need some data to select the model. Which model I have to select?
Correct.
That is called the validation data. Now you have divided the entire data available to you in two groups. One is training data and one is test data. Now this validation data, where it will come from? It will come from training data or test data?
Okay. Let me tell you this. Like in this way, okay. What I will do is I'll give you 100 data points. Okay. I'll give you 100 data points. What I will say is I'll tell you construct a model. and then give me the machine learning model. I will say, okay. I'll tell you that. So what you need to be doing is you can't use all the 100 data points. Okay. But for this 100 data points, you know the input and then you know the output. Okay. You can't use all the 100 data points. What you need to do is you need to divide that into two parts. One is for training and other is for testing. Okay. Using the training data, you'll build a model. Using the training data, you'll build a model, and using the test data, you'll evaluate how good your model is. Okay.
Correct.
How good your model is, and after that, what I will do is once you have done this testing, correct? That is here for the test data. If your model is performing very good, what you'll do is you'll submit your model to me. Okay, you'll submit your model to me. I will evaluate your model based on the data which I have. Okay, based on the data which I have. That is the evaluation data. Okay, that is the evaluation data. Or else, let's say like I'll give you the evaluation data too, but I will only give you the input values. I won't give you the output values.
No, sir, I get confused, sir. So you are giving me 100 data, right? 100 data point. Now,
Right.
first I have to select the model. Which model I am going to select, right? So there are 5 models available. Out of 5 models, which model I have to select? To select the model, what are the data point that I will use to choose the model? This part is not clear to me.
You're talking about
Out of
choosing
5, whichever
choosing
model
best
performs
model.
better in
Talking about
validation.
that part.
Because sir, one of the activity questions that I solved, and they said the entire data set is divided in two parts, training and test data. Now the validation means selection of model will come from the training data itself. This part, if you can clarify.
See, the selection of model, it comes from training data only. see the which model to select. We have the different models of like predicting, right? For regression and all, which model to select, that you'll be learning like later parts, like based on the accuracy of the test data, right? And the training data, based on that you'll be selecting the better model for it. Okay.
Okay. Actually,
Like,
my question is, if I select the model from the training data points, then the data point I used for selection means validation of that model or selection of the model, can I use that same set of data while train the model, or I have to discard those points which already used for the selection of model?
you have to obviously discuss those points. See, I just told that, right? See, we use some points for modeling the for creating the model. Okay. And then we'll discuss those points, and then we'll use the remaining points for testing the model. Okay. And then we'll use the remaining values for testing the model. Okay. These are the two sets of data. That is the training data and then the test data. Okay. There is a different data, that is a validation data. Okay. That is a validation data. That validation data, for the validation data, you do not know what the actual output is. You do not know what the actual output is. All you do is you just use your model to predict the output. That's it. Okay.
Okay. It will be clear in later part, right? Means in next week.
Yeah.
Okay.
You'll actually do the machine learning algorithms based on this one. What they do is, for example, let's say because see, we need to be grading you, right? We need to be grading you based on the machine learning model which you have created, right? What we do is we just give you, let's say, like 1,000 data points which are the input and the output. Okay. You will use those 1,000 data points for testing and training, and testing. Okay. That's it. That part is done. And then what I'll do is I'll give you another data which doesn't have the output. Since it doesn't have the output, all you can do is you can only predict it. Okay, you can only predict it, and based on your prediction, you'll upload your, you'll upload your results, right? Or let's say, like, you'll upload your output. Okay, and I will actually test like how well your model is based on the output values. I know the output values for the validation data. You do not know the output values. But for the training and test data, you know the output values as well as input values. Okay.
Okay.
Sir, one question.
Yeah.
Before we move on to next. So can we say that training data will be used to develop the model?
Yeah.
Okay. And my second question is that, so validation data point, I'm still a bit confused. I understand that for validation data, we will not be having output. We will be using the model which we generated from the training data, and we predict the output for validating the, for using that validation data. That point I understand. But in is this data things only for this course point of view, or in the real world also do we have like these type of three kinds of data, like training data, test data, and validation data? Because what my understanding is that this validation data could be like actual projects. Means they are asking that okay, you predict that value. Okay, that is kind of like an actual project.
See, yeah, actually, the validation data is the actual product. Okay, and is the actual thing which you need to do. Okay.
Yeah. Okay.
Okay. That is correct. That is correct. Even if you go across the real-time machine learning project, right? In the Kaggle and all, they have this validation data. Okay. Yeah. Okay.
Yeah.
They actually have this. Where you won't actually know the output. If you know the output, then there's no competition and all this, right? Okay.
Correct. Okay. Yeah. Now it is clear, sir. Now I understand.
Excuse me, sir. So.
Yeah.
So as you said that for validation data we won't have any output value, right?
I mean, you won't be knowing what the output is. Yeah.
Yes, sir. Then my doubt is that with respect to what value are we validating the output of the model selected model?
Yeah, for that we use the test data. I told you now, whatever input, I mean, whatever data I give you, you need to divide the data into two parts. I mean, for whatever data, you know, the input and output now, that you need to divide it into two parts. One is the training data, and other is the test data. You use the training data to build your model, and then you use the test data to check the accuracy of your model. Okay, got it?
Yes, sir. But we will have a fresh data for validation data.
Yeah, yeah.
Or are we taking some value from already from the data that we already have from training and testing data?
No, we don't have the same data. We have different data.
Okay, then how would we confirm that the output that our model is giving is correct or not? Because we don't
based on how well your model is performing on the training on the test data, right? Based on that you will know. Suppose let's say like in the training data, okay, in the training, right? Your model accuracy is better, and then even test data your model accuracy is better. Then there's like far more higher chance that your model will perform well in the evaluation data, validation data. Okay.
Okay, sir.
So now we'll move on to this unsupervised learning. Okay, as I told, for the unsupervised learning, there is no exactly like what should be the output of it. Okay, so basically in the unsupervised learning, we don't know what we are actually looking for and what actually we are doing, we could say. Okay, but then what we expect is based on the outputs of the machine learning, we expect it to give some useful results or some useful inferences, okay, from the data. Okay, suppose we have like, let's say, data of like n vectors. Okay, each vector is of d dimensions. Okay, what we do is we just in the unsupervised learning, we compress, explain, and group data. I'll explain about this compress, explain, and group data thing in a while. Okay, the compressed data, which is nothing but the dimensionality reduction. Okay, the group data is this density, is the density prediction one. Okay, clear. So for example, what we have is unsupervised learning is we give me a second. So what we have is we have this, for example, let's say like we have this Coca-Cola red tweets. Okay, let's say like we have this n number of tweets about this Coca-Cola. Okay, we don't know what we are going to do with this tweets. Okay, but what we try to what we try to get from this machine learning is we try to group the tweets into a particular category, and then based on that we try to get some inferences. Suppose like let's say so many number of people liked it, and then they posted a tweet about it, and then certain number of people did not like it, and then posted the tweets about it, and then some number of people just did that for a promotion. Okay, so this is kind of like explaining and then the grouping data. Okay, clear what I was trying to say?
No, sir.
Not clear? Suppose let's say like we have this Coca-Cola, right? We'll collect all the tweets that includes Coca-Cola in the tweet. Okay, that includes the word Coca-Cola in the tweet. Okay, we have collected the data, and then we don't know what we are going to do with the data. Like, I mean, we don't know what exactly to expect with the data. Okay. But then what we try to do is we try to group the tweets into different categories, and then try to make some inferences, and then try to understand that particular data which we have. That is 1 million tweets of this about this Coca-Cola. We try to group this tweets into a particular categories, and then try to understand about it. Okay. Suppose we have this.
This grouping means, can I say we are clustering this data in various zones?
Yeah.
Means is it same thing?
Yeah, it's the same thing.
Then how it is different from the classification? Because in classification we also segregate entire data in either 2 or 3 or 4 parts.
Yeah. Classification we have a input data, and here we don't have a input data.
We have the input data. In the classification, what happens is we don't know, we know what we are classifying the data into. That is we know whether we are classifying that into yes or no, like survive and did not survive, something like that. But here we do not know how we are clustering it, how we are grouping the data. We do not know.
Okay, that means we do not have the output here. Only input function is there. Okay.
Yeah. So here I told you, right? We just have the data of like input vectors. We do not have the output vectors here. That is why it is called as unsupervised learning. That is why, I mean, we are not telling the machine learning problem for this input, this is output. Actually, we are not telling there's no output, right? So it needs to learn from itself. From the data itself, it needs to try to group data and then like try to explain it. Okay. Okay. So this dimensionality reduction, it is just a way of like, suppose we have this n number of features. Okay, some 1,000 number of features, or like 10,000 number of features, right? Okay. Can we try to compress this number of features or the number of dimensions into a lesser dimensions without losing too much of information about it? Okay, that is what we mean by this dimensionality reduction. Okay, so by dimensionality reduction, we just do this compression and some simplification. That is, we reduce this 1,000 number of features into, let's say, like 10 number of features and so on. Okay. So for example, we have this represent a million gene expressions, right, of a million people using just 100 numbers per person. Okay, clear?
Yes, sir.
Okay, yeah. Okay, so here we have this. We have this vector of like d dimensions. Okay, we encode it. That is reduce the dimensions into d dash. Okay, where d dash should be less than d. It should be very much less than d. Then only our compression or like encoding makes sense. If it is not reducing the dimensions by much, then there is no point of like compressing it. Okay, and then the decoding is we will actually, I mean, we will increase the dimensions from d dash to d. Okay, clear? So by doing this encoding and decoding, our goal is that g of f of I mean, decoding the encoding one. By decoding the encoding one, we should get the same data. We should not lose like too much of information. It should be similar to the actual data. Okay, that should be the goal. Okay, so in this particular case, the loss function, it is calculated by this, the difference between the actual, I mean, the g of f of x of the decoding the encoding one and the actual xa values. Okay, the difference between that, using that difference, will be calculated in the loss function. Okay, clear?
Yes, sir.
Okay. So for example, we have this two dimensions one, 1.8, 2.2, 3, 3.4, 3.8, right? So we had this two, I mean, this is the encoding one, f of x, and then the g of u is the decoding one. Okay, if you have this f of x, we are just encoding it into x1 minus x2. So what happens is we have this 2 dimensions 1 comma 0.8. So the output for this will be encoded to 0.2. And then for 2.2, it will encode it to minus 0.2, 3.2, it will be minus 0.2 using this formula x1 minus x2. And then 3.8, it is 0.2. Okay. And then the decoding formula, I mean the function g of x, which was given as u comma u. Okay. So which will give me the decoding value as 0.2, 0.2, minus 0.2, 0.2, minus 0.2, minus 0.2, 0.2, 0.2. Okay. But then if you look at here, the g of f of x is nowhere close to the actual xi value. That is 0.2, 0.2 is nowhere close to 1.2. Minus 0.2 is nowhere close to 2.2. Okay. So this is just a bad model. Okay. So the other model is this f of x equals to x1 plus x2 by 2, and then g of u is u comma u. This is a good model because if you look at it, 1.8, right? It's going to give me 1 plus 0.8 by 2. It's going to give me 0.9. Okay. And then g of u is going to be 0.9 comma 0.9. Similarly, for 2 comma 2.2, f is going to be equals to 2.1 and g is going to be equal to 2.1 comma 2.1. It is not exactly equals to xi, but it is close to the actual the actual vector. Okay, the actual vector of 2 dimensions. So the second model is better when compared to the first model. Okay, clear? We reduce this 2 dimensions to 1 dimensions using this f function. Okay, and then we increase the dimensions from a single dimension to 2 dimensions using the g function. Okay.
So, sir, here the good model, which one will be the good model? It solely depend on fx, right? Because gu is always going to be u comma u, something like that.
It's see, in this particular example, it is the same, but it's not going to be the same for each problem.
Okay. It just can do what gx will do is it just convert the dimension like r d dash to d.
Okay. Yeah, f actually reduces the dimension, g increases the dimension.
It could be u by 2 and u by 3 like that.
Yeah.
Okay.
Excuse me, sir.
Yes.
How is the second set better than the first set of f and g?
Okay. I'll explain this here. Okay. So the same one x1 plus x2 by 2, we have these values here. Okay. 1 plus 0.8 by 2, it's going to be 0.9, and then g is going to be 0.9 comma 0.9 because we have this u comma u. Okay, similarly we have this 2.1 comma 2.1, 3.1 comma 3.1, 3.9 comma 3.9, right? So compare these values with respect to these values. Okay. Compare this g hat values with respect to g. Okay. The actual values of 0.9 comma 0.9, it's close to 1 comma 0.8, right? Similarly, 2.1 comma 2.1 is close to 2 comma 2.2 when compared to this 0.2 comma 0.2, right? So that is why this f hat comma g hat is better when compared to the previous model. The second model is better when compared to previous model. Okay. Clear? Okay. So this density estimation, what we do here is we actually estimate like whether that particular thing is corresponding to that particular value or not. That is, we have this question of like we create a robot account, okay, that generates, considering Mr. Chopra, okay, where he has created the tweets, right? Using his tweets data, okay, we'll create a robot account which creates like so many tweets. Okay, how well the robot account is close to the Mr. Chopra's tweet, right? That is that is what we are interested in. That property of like how close the robot account tweet is close to the Mr. Chopra's. That is given a tweet. Can you expect like whether the tweet is actually done by the done by the Mr. Chopra or not? Can you guess it? That's a question. Okay. That is his density estimation or like the probability estimation of it. Okay. Clear? The question is clear?
Yes, yes, sir.
Okay. So if you consider this example of this Twitter, right? Twitter tweets, right? We have this, the tweet can contain 128 characters, right? Okay, and then considering like each character, it could contain only the 26 26 English alphabets. So the possibilities for a tweet are 26 power 28, 128, right? Correct? Did you get what I was saying? We have this 128 character sentence, okay, and then each character there are like 26 possibilities considering only English alphabets, English small case or uppercase alphabets. Okay, so for a tweet there are like 26 power, 128 different possibilities of how a tweet could be. Correct?
Correct.
Yeah.
Clear?
Clear.
So is this clear now?
Yes, sir. Yes, sir.
Yeah, clear.
Okay. Yeah. So what happens is we have this 26 power 128, right? The probabilities, the sum of the probabilities of all those speeds, it should be equals to 1. It should be equals to 1. Okay. So and then the one which has the highest probability, right? Then that will be the one which will be close to this Mr. Chopra speed. Okay. We'll discuss that. Okay. So we have this probability mapping thing where we have this 26 dimensions. Sorry, not. Yeah, we actually did not include the space here. If we include the space, then it's going to be 27 power 128. There is not much of a difference there. Okay. So we have this data of like xn points, right? We have this points of like xn vectors, that is this 128 characters which are like possible, and then we have this we have this 26 power 128 possibilities, or 27 power 128 possibilities. Okay, the sum of the probabilities, the sum of the probabilities for all these different bits, it should be equals to 1. Okay, the sum of the probability mapping from these d dimensions, the sum should be equals to 1. Okay, here the loss function, it's going to be 1 by n into, the goal is the probability, right? It should be large if x belongs to data. What that basically means is, if that tweet is actually done by the Mr. Chopra, right, then the probability should be high. Otherwise it should be low. Okay, otherwise it should be low. So when we are doing this 1 by n into sum of I equals to 1, the loss function, I will explain why we took this minus 1. Okay, so the loss function is defined as the sum of I equals to 1 to n and all the logs of this different tweets. Okay, minus log of p of xi. Okay, if p of xi is large, that is if it is close to 1, then that actually means that it belongs to data, right? It belongs to data. So that means that when it belongs to data, which basically means that tweet was actually done by the Mr. Chopra. Okay, that tweet was actually done by Mr. Chopra. So the log value for that particular one, it will be close to 0. If it is not done by him, then the p of xi value, it will be low, right? That is, it will be close to 0. It will be close to 0. When it is close to 0, the minus log of it, it will be close to infinite, right? Okay, clear? Because when we look at this minus log of 0, right? Log of 0, it's going to be minus infinite. Minus of minus infinite, it's going to be close to infinite. I'm not telling that they won't be exactly equal to 0, but then it will be like close to 0, which makes the loss function to be like higher. Okay. Clear what I was trying to say? No?
Sir, sorry.
Yeah.
I mean, can you repeat that? What exactly the problem statement and what exactly? Because I mean, I was just listening, but still I couldn't connect it. Why? I mean, how are we saying that if P of X is large, then probably Chopra might have tweeted that one. I mean, I couldn't connect that.
Okay, we have these different possibilities of like the tweets, right? Different characters that could be there in the tweet, right? In the 128 character tweet, right? So the sum of those probabilities that should be equals to 1. That is a first set we have, because for the probability density, the sum of the probabilities should be equals to 1. Okay, and then if the tweet is actually done by Mr. Chopra, that is if it actually belongs to this. If the tweet actually belongs to the tweet that was done by Mr. Chopra, then P of X should be large. Okay. Any doubt there?
So this
equal to 128, right? Equal to 128, right?
P of X equals to 128. What are you saying? The dimensions, yeah.
Okay, so the data is all the tweets tweeted by Mr. Chopra, right?
Yeah, the data is all the tweets tweeted by Mr. Chopra, and then the P of X, it's going to be the all the different possible characters that are possible. I mean, all the different possible tweets.
Yes, it is like I have seen some random tweets, and now I'm searching it in data whether it's belong to the data or not.
Yeah. Okay, so if the tweet is actually in the data, I mean, like if the tweet is actually done by Mr. Chopra, then P of X should be large. Okay, and then it should be low otherwise. So when P of X is large, then minus log of P of X, it will be low. If P of X is low, which basically means P of X is close to 0, then minus log of P of X should be like very higher. Okay, which is basically the loss function, right? Okay, clear?
Yes, sir.
Yeah. Okay. So here we looked at this examples of like x1, x2, x3, x4. Okay, these are the 4 points which we have: 1.2, 1.9, 4.3, 4.8 on a normal x-axis. Okay, and then we took this first probability. I mean, the first probability function as uniform probability in 3, 10. Okay, in 3, 10. So basically, what that means is, if it is in between 3 to 10, then the probability is going to be 1/7. Otherwise, it's going to be 0. You know that uniform probability distribution, right?
Yes.
Right. Okay. So if it is going to be in the zone of 3 to 10, then it's going to be 1/7. Otherwise, it's going to be 0. Okay. So for this point of like 1.2 and 1.9, the probabilities are going to be 1/7 and 1/7. For the remaining, it's going to be 0. Okay. For P2, what they have done is, it is uniform in the range 0 to 10. So what's going to happen is, since 1.2, 1.9, 4.3, and 4.8, all those falls in the range of 0 to 10. For all of those, the values will be equals to 1/10, 1/10, 1/10, 1/10. That is the probabilities of them are correct. Okay. So similarly for P3, it is uniform in the range of 1 to 5. Since this x1 to x4, they all happened in the range of 1 to 5. The probabilities for all of them is going to be 1/4. 5 minus 1 is 4. So 1/4, 1/4, 1/4, 1/4. Okay. The P4, the assumed it is uniform in the range 3 to 5. So since 1.2 and 1.9 did not occur in the range of 3 to 5, the probabilities for that is 0, 0. And then 4.3 and 4.8 is in the range of 3, 5. So the probability for that is 1/2 and 1/2. Okay. Now what we do is, we calculate the loss function. Loss function for P4. Okay. For P4 it is infinite, because minus log of 0. That is, we have the 0 values, right, for x1 and x2. Since the since minus log of 0 is infinite, that is why loss for P4 and loss for P1, it's going to be infinite. Okay. And then if you look for loss of P2, that is going to be 1 by 10 loss of 1 by 10. I mean minus log of 1 by 10 into 4, right? Because it's the same values. Okay. So that loss value is going to be greater than the loss of P3. Okay. Clear what I was trying to say? If you compute the values of minus log of 1 by 10, right? And then that value is going to be greater than minus log of 1 by 4. Okay. That is why they said that loss for the P3 is less than loss for P2, or loss for P2 is greater than loss for P3. That is why among these models, P3 is the best one, since it has the lowest loss. Okay, clear?
Yes, sir.
Yes, sir. There is a question, sir. I'm not getting the meaning of x1 is equal to that value.
X1 equals
Yes.
to 1.2.
What is the meaning of that 1.2, 1.9, and 4.3?
See, these are the 4 data points which you have.
Sir, actually, when in the earlier slide, there is a, please, if you can scroll down to the earlier, in that x1, x2, actually, I was thinking that these are the particularly the statements of tweets done by Mr. Chopra, and from that, what we are doing, we are just taking the probability of each word matching in that earlier post. But the number is not, I'm getting, what is the meaning of this number?
Which one?
That in the later slide you have showed x1 is equal to 1.2 and 1.9, 4.3.
Okay. Consider this as like the tweets done by Chopra. Okay. This is some density estimation that was done. Okay. P1, P2, P3, P4. Okay. P1, P2, P3, P4, and then what we do is using this distribution, using these density estimations, we compute the loss. Okay, and whichever has the minimum loss.
Loss part, sir. Sir, mathematical calculation part is done, but this thing is not. I'm getting. What is the meaning of 1.2? Are this 1.2 is the number of words which are similar with this Mr. X to the earlier tweets, Mr. Chopra's earlier tweets? 1.2 words are similar, 1.9 words are similar from the last date of tweets done by that X-man.
See, this 1.2, 1.9, 4.3, and 4.8. Those are the data points which actually exist. Okay. So for that we are calculating the density estimations. Okay.
In the context of tweets, what exactly meaning of the x1, x2, x3, x4? That's what the question, I think.
Okay.
Yes,
So consider this as like a tweet. Okay, this is a tweet 1, tweet 2, tweet 3, tweet 4 done by Mr. Chopra. Okay. So with respect to that, with respect to the first density estimation, right? The first 2 tweets are not done by Mr. Chopra at all. The first 2 tweets, these are not at all done by Mr. Chopra at all. Okay.
All right.
So which basically gives the loss function as like infinite.
All
the
right.
P1 and P4, according to that, these 2 tweets are not done by Mr. Chopra at all.
All right.
So what exactly represents this x1, x2, x3, x4?
Yeah, I just told you that they represent the data which we need to estimate the probability density for.
We can say that these are the tweets from Mr. Chopra. X1, X2, X3, X4 are the tweets from Mr. Chopra.
Yeah.
And P1 is some model. We say P1 is a model which is going to say whether these tweets are belong to Mr. Chopra or not. So this is like what it is.
Yeah.
No, model part and calculation part is all right. There is no issue, but not able to get the physical meaning or significance of this 1.2.
So you can, okay. I think we can say that instead of 1.2, we can say that I am Mr. Chopra. This is the tweet. and then the model is saying that I am Mr. Chopra and we all are Mr. Chopra. These are the tweets in some model. So we can understand like that instead of 1.2.
How can we
The
put it
numbers
in
are
the model?
repeating the tweets.
Hello.
What can we
Yeah.
consider is basically 3 to 10 is something what P1 tells is Mr. Chopra will be always putting number between 3 to 10. P2 is telling it will always between 0 to 10. P3 is something 1 to 5. So 1 to 5 is something which is very precise, and whatever the four numbers which had come x1, x2, x3, x4, it comes very concise in that. That's why it is a better estimation of what Mr. Chopra is saying. I think that is what I felt this model is telling here. Please correct me if I'm wrong.
Yeah, what you said was like very close to the exact one, yeah, and it actually relates to the problem. Yeah, you're correct.
Thank you.
So see, what we're basically trying to do is we have these numbers or like the points which is scattered, right? Which is scattered, and for those points we estimate the density. So which is using whatever density distributions we have, okay, we estimate the densities for each of the data points, and then we compute the losses for it. Whichever has the least loss, then that will be that will be the best model. Okay, that will be the best density estimation. Okay, clear?
The question was how to get the number from the tweets.
What?
The numbers with the 1.2, 1.9, 4.6, 4.8. How to get these numbers from the tweets? Like which are the words, right?
How to get these numbers from the
tweets?
See, this doesn't exactly correlate to the previous problem. This is just that is just a real world example. This is just an example that illustrates this density estimation. These are not exactly relatable. So what I told was, I just tried to relate those two. That's it. Okay. These numbers is nowhere related to the which one. Okay. Clear?
Hello, sir.
Yeah.
Sir, when we will discuss problems on loss concepts, sir, calculating loss by x, y, z, and giving function that concepts. Means to say particularly in graded we have lost in the lost we have some problems, right, sir? We are getting some error in it. I mean, how by calculating squared mean error like that.
Yeah. We'll discuss that. Like we have like one more session Saturday, right? We'll discuss it there. Okay. So there we have this solve within the problems, and along with that we'll discuss similar problems on that line. Okay.
Okay. In this session we are discussing about concepts only, right, sir?
Yeah. We are supposed to discuss the activity, but then we do not have time for that.
Oh, okay, sir. Thank you.
Yeah. Okay. So we look at
So for each value of 1.2, 1.9, 4.3, and 4.8, can we say that each value represents a function on each of the tweets, and we arrive at that value when that function is applied, and we give a probability to each of the values, and we are trying to estimate the probability out of that values? Have you understood?
No, I did not exactly get what you meant. Can you repeat it?
See, there are four values, right? 1.2, 1.9, 4.3, and 4.8. Each value is a function. Suppose there are four tweets, you apply a function and these four numbers turn up. You apply a function on that statement, right?
I mean, do not relate that to tweets. I mean, like, do not think of it like we apply those tweets and then we get this number. So think of it like those are like four numbers. I mean, four data points, which are on the x-axis. Okay. So for that we need to estimate the probability densities, right? Okay. So the exact value is, I mean, the exact thing that should be happening is the sum of those four probabilities, it should be equal to 1. Okay. And then the remaining, it should be equal to 0.
Okay? No, but when the instructor says generally where we use density estimation in the lecture, where the instructor says is we want to predict more values, but we don't have data, but it is not feasible. That is what the instructor says. Like the medical data, that is what the lecture says. So
yeah.
So we have these 4 values. We have more values. So that is why we are doing a density function. It is not that these 4 values cumulatively represent probability of 1. We are just giving it, they lie in the probabilities.
No, like what I meant to say was, see, if you're just catering to this exact model, and then ideally what you said was correct. If you look at if you include the more data points, right? I mean, it'll be more of that continuous probability one. That is correct. Like if you're looking for this, I mean, if you're purely looking from this model itself, okay, and not looking at the reality, right? So for you to get the least loss, only for this, I mean, only for these 4 points, right? The loss should be, I mean, the sum of these loss should be equal to 1, and the remaining it should be 0. But then that won't be actually equal to the ideal case, as I said, because we have the more points, and which do not have the 0 values. Correct.
So you are saying that in respect to P1, P2, P3, P4, we should only minimize the loss with respect to these 4 points and not worry about the rest.
Yeah, and then like, yeah, that is true. With respect to this, yeah, and then if you actually know, suppose like let's say if you're talking about this medical problems, right? If you actually know that it follows a particular distribution, right? Then what you do is using these 4 points, you try to get that particular distribution. That's what we try to do. Yeah.
So okay, so it's clear.
Yeah. Okay. So now we'll try to solve the problems. Okay. The activity questions, it should be clear, I guess, but then we'll still have a look at it. Okay. So I won't look at this first lecture because that's kind of easy. I'll go from the lecture 1.4. The classification models are predictive models, they are not probabilistic. Probabilistic models are different. So for the classification models, the loss function, this also should be straightforward. We evaluate a model based on this test data. Yeah, we do this. Okay, we build a model using this training data, and then we evaluate based on test data, and then we predict for this validation data. Okay, the model selection is done using this validation data. Okay, the best model will be selecting. I mean, among the different models, right? We select the best model using the validation data. Samit was asking a question, right? Like, which model should be selecting? Which is the best model? So based on this validation data, okay. So as I told, for the unsupervised learning, we do not have the output. So all we do is with the input data, we just try to understand the data. We won't do the curve fitting. That happens for the supervised learning. Even the classification of the predictive learning, that is for the supervised learning. Okay. So, and then for the encoding, the dimension should be reduced. So t should be greater than d dash. Even for the decoding, the dimension of d dash should be less than d. So d should be greater than d dash. Okay. This one, yeah, this is just a way of like checking whether our encoding and decoding is actually correct or not. Okay, in the loss function. So whichever has the least loss, then that is the best one, best encode and decode for that particular data. Okay. So the input data for unsupervised learning, this should be clear because we do not actually have the output there. So that's why option 1 and 2 are wrong. I'm sorry, 2 and 3 are wrong. The probabilistic model is the density estimation, as we have seen. And then there is the loss function that should be also straightforward. The negative log likelihood, because we have this negative log over there. Okay, that is why the parameter estimation for a density estimation method, right? So that is a negative log likelihood. Okay. So the practice assignment we'll look at in the next session. Okay. Clear?
Yes, sir.
Okay. So thanks everyone. Okay. We'll meet in the next session. Okay. By the time, try to go over the contents of it. Okay. Yeah. Thanks everyone.
Okay. Thank you, sir.
Thank you.
Thank you, sir.